Okay, this is the same model I had last time, only I've hidden everything except the sketch and one set of drivers. This is a 300-foot radius. I've got a 42.5-inch offset, which is just a number I picked because it ended up with geometry that looked reasonable based on what I wanted to show last time. So this radius is that much bigger than this radius. And the arc length is 10 degrees. So we're coming in at -5 and we're leaving at +5. And we've done it over a radius of 300 feet. Well, for that configuration, this inner arc is traveling it has an arc length that needs to travel of 628 inches. The outer is longer at 635 inches. Now, if we had a straight axle with two tires of the same diameter and therefore the same circumference, the distance that tire travels is going to be the circumference times the number of rotations. Well, in this case, we know how far we want to go, so we divide the circumference, and that's how many rotations we need to get. With a fixed axle, same size tires, we're going to have that same distance over here. So if this only travels 628, you see it's coming up short. And the further around we go, 20 degrees, 30 degrees, the worse it's going to get. The tighter this radius, the worse it's going to get. You're putting a lot of stress on your axle, and eventually the tire is going to slip. Well, in a car, they put in a differential. You got the motor input, and it basically will divide between the two tires based on force, and if they're in good contact with the road, then it's basically going to find its own ratio as you go around a curve. Going straight, it would have a 1-to-1 ratio. Well, we can't use a differential on a train. For one thing, power's not coming in via a drive shaft running this axle. It's coming in by two steam cylinders. So to change the velocities of one side versus the other, we'd have to differentiate the steam flow. And it would be different for every single curve. It just isn't feasible. You need it to be automatic. Now in a train, you definitely can't spin a tire to make up the difference. You're going to have to figure out a way to differentiate, because spinning a tire can damage the tire and or the track. Well, that's why this isn't a cylinder, it's a cone. There's not one set diameter. So what's going to happen in a curve left to its own devices is it's going to find an equilibrium point, and the tire on the wheel, well, the driver, since we're talking trains, the driver on the inside of the curve is going to tend to ride with the track toward the outside, where the diameter is smaller, therefore the circumference is smaller, the distance it travels per revolution is smaller, while the outside is going to tend towards the inside of the cone, where the diameter is larger and therefore the circumference is larger. And it's going to work it out on its own. You're not going to have to do it, but if you were to take measurements, you'd find a proportion of your diameters matching the proportion of your arc length. And it's just going to find that automatically. Now you might say, yeah, but you can't go wherever it wants because you got 4 of these in a row. Well, the next one down is basically going to be symmetric with this. So whatever diameters it finds, the next one's probably going to find the same. The next one up, however, is going straight out, and this is curving away, so it can't hit the exact same diameter. And it doesn't have to. What it has to have is the same ratio. And so each wheel can find its own diameters. It's the ratio of arc length that we have to hit. So each wheel can be distinct. Another saving grace that helps, since we have two competing things going on, the need to fit the wheels and the need to differentiate the speeds, Another saving grace is nothing in the world is truly rigid. Everything has some give. A train is a huge number of pieces, and if each piece contributes a little bit of give, then on the whole, there's a lot of give. So your train as an overall unit, it's basically going to find its own equilibrium of where the tires need to fall to make the curve and where the tires need to fall to have the right speeds to cover the right distance during the curve. And it's just going to work out if it's a well-designed engine. Certainly there have been designs where it hasn't worked out so well and they've had to tweak some things to get it to work out. But towards the end of the steam era, things were pretty well nailed down.